beautiful arrangement. Right? So for this problem, we're given an integer n, and from 1 through n, we have n numbers which form a list. And this question is asking us to find out whether like how many beautiful arrangement are there for the list of numbers. So what does beautiful arrangement mean? So it means that for every single element in the list, right, either the value is going to be divisible by the index, or the index is going to be divisible by the value. So if it applies to every single number of the list, then we say this is a beautiful arrangement. Okay. So by examining example in here, so we have n equals to 2. So we're gonna have an arrangement saying 1 and 2. So first we have the number 1, and second we have the number 2. And the second arrangement we can have is 2 and 1. So in both cases we can see that so all the elements in here, either the value is divisible by the index, or the index is divisible by the value. For example, in this case, the index is divisible by the value. So we have two beautiful arrangements, and we're gonna output 2 for this example. All right. So intuitively, by looking at this question, what we can think is, suppose like n equals to 5, we know that the available number pool to choose is 1 to 5, right? So we're gonna have a list of 1 through 5, and we're gonna have index. Index will be fixed 1 through 5. So for each of the permutation, we can arrange the number as this, like 1, 2, 3, 4, 5, or 2, 1, 3, 4, 5, or etc. etc. So intuitively, what we can do is we get all the permutations based on the pool of numbers, and we're gonna check each of the permutations, so whether this one is a good arrangement and whether this one is a good arrangement. And then finally, we're going to output how many good arrangements are there, right? A good arrangement, as we talked before, is we're going to compare the index and the value, right? So if either of them can be divisible by another, then we're going to keep going and then checking until like every single one of them meets the condition. Then we say, oh, this is a good arrangement. For example, the first one will be a good arrangement. The second one will also be a good arrangement, right? Yeah. So by knowing this, now the question becomes, how do we find the all the permutations, right? So based on the available pool numbers to choose. So intuitively, what we can do is sort of do it in a recursive way, because we pick the number one by one. So suppose we pick the number 1 in here for the first index. It become a sub-problem where we're also gonna pick numbers from a pool, but with the second index, right? So we only pick 4 numbers now, and then it further shrinks to another smaller problem where we do the same thing, where we pick from the pool, but only pick for the third index, fourth index, and fifth index, right? The only thing to notice is we cannot pick the number that has been picked before. So we're going to have something to denote, okay, so we picked 1 and picked 2. So with this sub-problem, we cannot pick 1 and 2, but we can pick other numbers from the pool, right? Yeah. And so on and so forth. After we're done with this first recursion, right? And we're gonna think, hey, we picked 1 at first for index 1, and then next time we're gonna pick 2, right? So for each of the elements, each of the indexes, we're gonna pick every possible choices of the numbers. So because like from the beginning, 1 is possible, 2 is possible, and until 5 always possible. But then like for here, when we choose 2 already, so 2 won't be possible for the rest of the choices. So only 1, 3, and then 4 and 5 will be possible. Okay, so by knowing that, let's take a look at the code. All right, so the main part is the check method. So the check method, as you can see, it takes a index and then it takes a selected. So this selected, as what I was mentioning before, is a data structure. It's an array to save what has been selected before. So if it has been selected before, we cannot pick it again, right? And n is the number that has been inputted, that how many available pool numbers is in the pool, right? Okay, so base condition. So if we already check the index is greater than n, then we're gonna return directly because we finished all the picking. So I denotes that we are picking for index I, right? So if in this case n is 5, we already picked 5. I will be 6, and then we're already done with all the picking. So and we augment the result and then return. Okay, and let's see here. So here is like now we are working on a certain I. Suppose I is 2. So we're gonna iterate through all the available numbers in the pool, which is 1 through n. In this case, is 1 to 5. And for each of the choices, we're gonna check whether it has been selected before, right? So if it has been selected before, in this case, like maybe 1 has been selected before, then we won't pick it. Okay, if it's not selected, it's one of the good candidates. And now we're going to check this is to check the good arrangement condition. So j is going to be the number, I is going to be the index, right? Because we're picking it for index 2 in here. So if the value is divisible by the index, or is it the other way around, the index is divisible by the value, if we cannot find such a condition, then we continue, because we know this digit doesn't satisfy the good arrangement condition, which means like we don't have to further pick for the next number and so on and so forth. We're gonna directly continue for another choice, right? For this particular I. And then now, if somehow this gets passed, this basically is a good arrangement for this so far, right? And then we're gonna mark this digit, this value as selected, and then further do a subproblem where we gonna pick I plus 1. We're gonna pick the third index, right, with the selected and with the n. So after that, note, we have to do something like this. We have to remove the value j from the selected. Why we have to do that? Because for the next iteration, the index I, which is currently is 2, right? The index I will not pick j anymore. So which means that it will pick another number, which means like j is going to be able to be selected by future indexes. So that's why we're gonna remove j from selected, and then it iterates through another round to pick for I, so that we don't miss any result. Okay, so after this is done, so remember, like if certain values are not meet the condition for good arrangement, then we already continued. So we don't even start with the next subproblem. Okay, so only if every single digit has been meet the good arrangement condition, then we can have our I at the end being a value greater than n. So that's where we're gonna add our result for good arrangement, and finally, like the code will return the result after the check method.